In a previous video, I added authorization-based encryption to Cypherly. Cypherly is an app that makes it easy to share secrets with others over public channels. For example, if you want to share a secret with Alice, you can use Cypherly to encrypt a message using Alice's email address. Then you can send Alice the Cypherly payload over Slack, for example. In order for Alice to decrypt the payload, she will need to first authenticate with Cypherly. Authentication with Cypherly currently uses sign-in with Google. In this video, we'll explain how sign-in with Google works by adding it to the TimeGetter web app. TimeGetter is a SvelteKit web app I created in a previous video that fetches the time from a server that we wrote in Rust using the Rocket web framework. Using sign-in with Google, our Rocket server will be able to know the identity of the user that is trying to fetch the time. Okay, let's get started. Here's the roadmap to get sign-in with Google to work. Initially, in the browser, the user signs in using their Google account and is issued a token, and the server fetches Google's public keys. Then, for every subsequent request to the server, the user calls our server's getTime endpoint passing their Google token. The server validates the token using Google's public keys. If validation succeeds, the server returns the time. Otherwise, it returns an unauthorized error. All right, enough talk. Let's demo. Here's the TimeGetter app. Currently, we're not logged in. If we click the Get Time button, we get a 401 unauthorized error. Let's log in. And now let's click the Get Time button again. This time we see a welcome message and our current time. So how does it work? Well, before we start, we need to configure our OAuth consent screen and create an OAuth 2 client ID. TimeGetter is reusing Cypherly's OAuth configuration and client ID. To do this for your app, navigate to the Google API console page, configure your OAuth consent screen. Then go to the credentials page and create a new OAuth client ID. Give it a name and set the authorized JavaScript origins. Click the Create button. Then we'll get the client ID in this dialog box. Copy the value. In our client code, we use the Google OAuth GSI library to create the Sign In with Google button. Paste the client ID here. When the user's login succeeds, we will get a JSON web token, also known as a JWT. Here's an example JWT. It consists of three parts: the header, the payload, and the signature. The header has information about what algorithm is used and a KID field, which identifies the key that was used to sign the token. The payload contains a set of claims from Google's auth server. If the token's signature is valid, then we can trust that the claims have not been tampered with. I've tampered with this JWT to hide my personally identifiable information. So if we scroll down, we can see that the signature is invalid. Tokens that use the RS-256 algorithm are signed using the private key of a public-private key pair. We can validate the token and prove that the token was not tampered with if we have the public key. For now, this is all you need to know. But if you're especially curious, Computerphile has done an excellent primer. They should show up as a card somewhere around here. So, in order to validate the token, we need Google's public key. We can get it at this URL. In this case, there are two public keys. The one that was used to sign our JWT is the one where the KID matches the token's KID. Our Rocket server needs to get these keys. So, in Rust, we have a fetch function that uses the request library to make a call to the Google public keys URL. This function is called @startup, and these keys are made available to every call in our server. Now, when the user clicks the Get Time button, the fetch time function gets called, and we pass the JWT as an authorization bearer token. This calls our time function in Rust. The time function takes this claims argument, which is produced by this Rust request guard. The purpose of the request guard is to validate the token. So here are the validation steps. First, we get Google's public keys. Then, we extract the authorization header from the request. If that fails, we return unauthorized.
Right to jail, right away.
Then, we extract the bearer token, parse the header, and get the KID that signed the token. If anything fails, unauthorized.
Also jail.
Once we have the KID, we can get the corresponding key from Google's public keys. Then we call decode, which validates the bearer token using Google's public key, as well as a list of expected claims. In our case, we ensure that the algorithm is RS-256, the audience is this thing, and the issuer is Google. If that succeeds, we return the decoded claims, which for our server are the user's email, name, and token expiration time. Back in our time function, we return the time along with a little greeting saying hello to the authenticated user. TimeGetter and the pull request that introduces sign-in with Google is MIT licensed and is available on GitHub. As usual, relevant links are in the description. If you like this video, hit the thumbs up. I'm the Friendly TL, and I make videos about useful open source apps that I also make, such as Cypherly, Codenim, and Hexly. If you're interested in the apps that I maintain and the new apps that I'll be making in the future, subscribe. Thanks for watching, and I'll see you in the next one.